Okay, this lesson is a two-part lesson on Newton's first and second law. So this lesson is the part one of the Newton first and second law. So it will be on the basic definition and some application of this first and second law. So the content will simply be the definition of Newton's first law, examples of Newton's first law, definition of second law, and examples of second law. So before we start, we need to first know something that's very important, and that is what is a resultant force. It is actually an overall effect of all forces acting on a body. It is a single force that can give the same effect as the many forces that acts on a body. Okay, okay, let's look at some examples. Now, if let's say you have many forces acting on a block, okay, in the first case, let's say there are 4 forces here. So in order to find, you can actually simplify these forces into one single force that can represent all these forces, and it's actually 3 Newton to the right. So what happened is that the 2 Newton and this 4 Newton actually subtract because they are in opposite direction, leaving only a resultant force of 3 Newton. In the second case, the 4 Newton and the 2 Newton subtracts, while the 6 Newton subtracts. That's why you will have no resultant force in the second case. So in actual fact, you can use either 3 Newton to the right to represent all these forces, and in the second case, the effect of all the forces acting together is the same as having no resultant force. So what is Newton's first law? So Newton's first law states that when the resultant force acting on a body is 0, the body will either stay at rest or move at a constant speed in a straight line. Okay, one of the important things that I would like to stress is that you need to remember that the body is either at rest or moving at a constant speed in a straight line, and not simply constant speed. Okay, there's a difference between constant speed and constant speed in a straight line. So because of Newton's first law, okay, it is in a nutshell, there's no resultant force. Because of that, the body will have no acceleration, and because of that, the body will either be at rest or it move at a constant speed in a straight line. Alright, so this is a summary of Newton's first law. So let's look at some examples. Okay, in these 3 cases, there are cases that fulfill Newton's first law, and hence they have no resultant force. Okay, in the first case, the block is at rest on the table. In the second case, the car is traveling at constant speed of 50 km/h in the straight line, and in the third case, the parachute is falling at terminal velocity. Now, how do we know that they fulfill Newton's first law? Obviously, they must either be at rest, or the body must be traveling at constant speed in the straight line, or there is no acceleration. So if you look at these 3 cases, in the first case, it fulfills the first criteria, is at rest. In the second case, it fulfills the second criteria of constant speed in the straight line. In the third case, terminal velocity actually meant that the body is falling at a maximum constant velocity. That means that the body is falling at a constant velocity. Now, velocity is a vector quantity, so by saying that it's a constant velocity, it meant that its magnitude and direction is constant. So that means it is also traveling at a constant speed in a straight line. So it will fulfill the second criteria. Okay, let's move on. So what is second law? Second law states that when the resultant force acting on the body is non-zero, the body will accelerate in the direction of the resultant force. The product of the mass and the acceleration gives the resultant force. So in a nutshell, the Newton's second law is that of a resultant force law, and because of resultant force, there will be acceleration, and the object will accelerate in the direction of the resultant force. And finally, the formula is F net is equal to ma, okay, where F net is actually resultant force, m is the mass, and a is acceleration. So resultant force is equal to mass times acceleration. So here are some examples of Newton's second law that fulfills Newton's second law, and because of that, they have resultant force. First case is a 200 kg motorcycle accelerating at 2 meters per second. Second case is a 50 gram bullet that slows down from 500 meters per second to 100 meters per second. And the third case is a car that goes around a bend at a constant speed of 20 km/h. Now, what is the criteria that we can see from these three examples that fulfills Newton's second law? So either the body must be at rest, the body has acceleration, or a body must have a change in velocity, which can be a change in magnitude or direction. So in the first case, obviously it fulfills the first criteria, it is accelerating. In the second case, if it fulfills the second criteria, there is a change in velocity because there is a change in magnitude of the velocity. In the third case, it is not easy to see, but you need to know that so long as there's a change either in magnitude or direction, there is a change in velocity, and hence there is resultant force. So in this case, although there is constant speed of 20 km per hour, the object is moving around a bend. So obviously, when it moves around a bend, there will be a change in direction. So this case will still fulfill Newton's second law. Alright, so there's resultant force. So in a nutshell, Newton's first law is a law of no resultant force. Newton's second law is a law where there is resultant force. So when there is no resultant force, there will be no acceleration, and when there's no acceleration, the object will be at rest or constant speed in a straight line. And when there's resultant force, the object will accelerate, and because it will accelerate, the formula will be F net equal to ma. Now let's look at some examples where we mix the first and second law. I just want you to try and figure out whether in these 6 examples, which one has no resultant force and which one has resultant force. Okay, you may want to pause the video at this point in time and try it. Okay, so now I expect that you have already finished writing down your answer. Let's go through together. First question, the book at rest on a table. Obviously, there is no resultant force because it is at rest. Second, rocket lifts vertically upwards at a constant speed. Obviously, there's no resultant force because number 1, constant speed. Number 2, vertically upwards, which means constant speed in a straight line. Alright. Number 3, a frog leaps vertically up from rest and achieve a maximum speed of 5 meters per second. Obviously, there is resultant force. Why? Because there is a change in speed, change in velocity from 0, which is at rest, to 5 meters per second. Number 4, a car cruises at the maximum velocity of 200 km per hour. Obviously, there is no resultant force. Why? Because maximum velocity meant that the car has already reached a constant velocity. So there is no change in the velocity. And maximum constant velocity also referred to as constant speed in a straight line. So there is no resultant force. Next one, obviously for change in speed from 40 meters per second to 10 meters per second, there is resultant force because of a change in the speed. Lastly, a roller coaster travels around a loop at a constant speed of 50 km per hour. In this case, there is resultant force. Why? Because there is a change in direction even though the speed is the same. So when there's a change in direction, there will be a change in velocity. So there will still be acceleration and hence resultant force. Okay, so that's it for this lesson. I hope that it managed to clarify the difference between the first and second law. In the second lesson, we will learn a little bit more about certain misconception and also how to apply the second law more effectively. So thank you and have a nice day.